Hi, hello everyone. In this video, I'm going to demonstrate the other example of normal stress calculation. Example 7.7 in the textbook. Okay, here, yeah, let's see what the problem looks like. Okay, say there's a member AC. Okay, member AC means this here, a member AC. Okay, member means some mechanical parts called member. Okay, member AC shown in this figure is subject to a vertical force 3 kilonewton here, 3 kilonewton point down here. Vertical force determine the position of the x of this force so that average compressive stress at the smooth support C. Okay, so you can say C is the smooth support, and so that the average compressed stress. Okay, this smooth support has a compressive. Okay, has a compressive stress. I see is equal to the average tensile stress in the tied rod AB. Okay, so we say this member C here is subject to external force, and then this supports, and this lead to the compressive and the tensile stress at the rod AB. And he say what's the distance x to make this tensile stress is equal to the compressive stress at C, and it give you the cross section area of this rod. Okay, and contact area at C here. Okay, C is here. Okay, C, I think C is here. Okay, C is here. Yeah, it's very small patch here. Okay, this is C, and it's 650 millimeters square. Okay. Okay, so let's draw this some picture of this question. Okay, let's just rethink about this problem. Okay, and I think this problem has some detail we need to about. Okay, okay, so okay here, okay, so I think here is the in the textbook show the free body diagram of this member AC. Okay, let's see. Yeah, let's look at the description of this problem again. He said the position force that this smooth support C here, it has a compressive stress. Okay, so that means this support C is here. I think C is here. C is here. I think it's very tiny patch C. It said this C has a compressive stress. Okay, compressive stress. This compressive stress. And A here, okay, rod AB here. The AB, what does it say? And the AB has a this rod AB has a tensile stress. Tensile stress. It's a tensile stress. And it's A, it's B, it's C. Okay. So okay, so that's a description of the problem. But let's look at, okay, AB rod subject to tensile stress, and the C is subject to a compressive stress. Okay, and it's a direction of compressive stress, and this is a direction of tensile stress. But let's look at this free body diagram. Okay, this free body diagram. Okay, maybe you may be wondering why in this free body diagram, why is why the direction the force is FC is point up and FAB is also point up? Because it say this problem say AB subject to a tensile, so the force at A should be point down, and the force at C should be also be point down. Okay, but in this free body diagram, why these two forces are to point up? Yeah, if you so that here this might need some little explanation. Okay, I think this should be the action and reaction. Okay, this tensile stress here, okay, this tensile stress here, it will have a reaction force. Okay, there will be a reaction force. Okay, this tensile here. Okay, let me go on this graph. is a tensile here, and this here is the compression here. There's a small compression here. Okay, and this tensile stress is acting on this rod, So there must be a reaction force acting on this member. Okay, that's why this action-reaction pair. Okay, there's a compressive stress acting on these smooth supports. Also, there is reaction force acting on this member point up. Okay, so this is actually called action-reaction pair. Action-reaction pair. 作用力反作用力 C action-reaction pair with still Newton's third law of motion. Okay, this also action and reaction pair. And apt to make a more clear explanation is this force is acting on the rod, or support. Okay, but the reaction force is acting on the member AC. Okay, this is very important. When you draw the free body diagram, you need to draw the force acting on this body. Yeah, you need to draw the force acting on this body. That's why in this free body diagram, he draw these two reaction force, because these two force is really acting on this body. Okay, that's why he drew these two reaction force in this free body diagram. Yeah, that's all I want to talk about. We need some explanation in this. Okay, so let's start with this problem. Jose, okay, he want to find us the distance here. Okay, the distance here, x, and this distance will make the tensile the average tensile stress in the rod AB is equal to the compressive stress at C. So what does that mean? Okay, he says, so very simply speaking, the problem just give us this condition. Average compressive stress is equal to average rod A. So what does this paragraph mean? It says compressive stress means stress is the same. So that means FAB divided by AAB is equal to FC divided by AAC. Okay. So, and this problem give you the area, the rod cross-section area of rod AB. So, okay, we have AAB, and also give you the area of the smooth support C. So we have known the area. Okay, so, and okay, so can we find the x here? How to find the x here? Looks like this equation is not, doesn't have anything about this x. Okay, so okay, let's start with. Okay, don't worry about that. Okay, because like I said, in this mechanics of material, in this course, everything is statics. Everything is static. Okay, so let's tell you, no translation, no rotation. No translation, rotation. So, and this problem is 2D problem. So what tell you? So that means sigma fx is equal to 0, right? And sigma ffy is equal to 0. And the total moment of the system, okay? Total moment of the system. In this problem we choose which reference point? Let's see. Reference point, which we should choose? Okay, let's choose C as a reference point. Okay, so let's try. Okay, so summation fx equal to 0. Yeah, we look at these three forces. It's all vertical force. So there is no component, no x component. So this must be 0. Yeah, it must be 0. Yeah. Okay, we don't need any equation. So let's see. Okay, the y component is 0. Okay, so this is a point up. So FAB and 3 kilonewton point down. Okay, so let's use kilonewton as the unit. Okay, so let's say I minus 3 and plus FC equal to 0. Okay, and don't forget this means kilonewton. Okay, and also let's the total moment of system is 0. Okay, so we use the C as a reference point. So okay, so FAB is here. So its lever arm is 200 times 10 to the power minus 3 meter. Okay, and it will create a clockwise rotation. So that means it's negative. So it's minus FAB times 20 times 10 to the power minus 3. Okay, meter. Okay, and this force also create the moment with respect to c. Okay, so this 3 kilonewton point down reference point here, so you will generate a counterclockwise rotation. Counterclockwise is positive, so it's plus 3 times what's the lever arm? Okay, lever arm is here. Okay, lever arm is here. This 4 lever arm is here, so it's 200 minus x. It's 200 minus x, but don't forget it's 10 times power minus 3. Okay, FC, but FC is acting on the reference point, so there's no lever arm. So to 0. So okay, so what do we have? Okay, so we have can we solve this problem? Okay, we got this equation. Unknown is FAB, FC. This is another equation. Yeah, FAB is unknown, but we have another unknown X. We have another unknown X. That's a huge problem. Okay, this is our unknowns here. Our unknowns here. Now we totally have 3 unknowns. 3 unknowns, but we only have 2 equations. How to do that? How to do that? How to do that? Okay, so that's why this problem give you this condition, this green condition. Okay, this is the first equation, this is the second equation, and finally this is the third equation here. Okay, that's why this problem must give you this description because this is another condition. Okay, if the problem doesn't give you this condition, you cannot solve. You'll never solve the problem because there are 2 equations, 3 unknowns. You never solve it at all. You never get a solution. Okay, okay, that's why we need these 3. It's not easy to solve, right? It's not easy to solve. That's really true. Okay, so let's start with okay, FAB. Let's start with the third one. Okay, I think third one. Sometimes third one must be easy. Okay. Okay, let's start with the third one. Okay, so FAB we don't know. Okay, and what's the area AB is? The AB is area AB is 400 millimeter square. So that's 400 times millimeter square. Be careful for prefix rule. Okay, and FC what's the area is 650 times 10 to the power minus 3 millimeter square. Okay. So after this equation, it gives you the ratio between the FAB and FC. So what's the answer? I think should be you can simplify as 400 square equal to FC 650 square. So what's the FAB FC? The ratio FAB FC. Okay, so I think this give you a check by yourself. Check by yourself, okay, because I don't have many time to do the calculation here. So check yourself. Here I think I think you will have FC is probably FC 1.625 FAB. Let me check. Let me check. Okay. 100 square divided by 400 square. Oh, no? Did I do calculations wrong? Oh, did I do something 1 millimeter square? Mm-hmm. No, no, did I do something wrong? Oh, no, 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 no. Millimeter square. Ah, sorry, I did this wrong. Okay, so there's no square here. Okay, so I did this wrong. Here. Da, 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 da. Only, I think it's only here. Here, here. So there's no square here. Okay, okay, that's the truth. Okay, let me check it again. Yeah, okay. So we got this relationship. So okay, we got this relationship. So we have used this relation and this two because this co-UFC is equal to 1.625 FAB. So okay, you put this in with these two. Okay, FC equal to 1.625 FAB and FAB plus FC is equal to 3. Okay, and be careful right now. This is 3 is means 3 kilonewton. So what is the F? So we can solve the FAB. Okay, FC equal to, so what's the FAB? I think it's very easy to solve FC. So FAB is equal to 3 divided by 2.625. So 1.143 kilonewton. Okay, so what's the FC? So it's 3 minus 1.143. Okay, so it's 1.857 and it's kilonewton. Okay, and next we have FAB. So FAB, you can plug the FAB in there, and then we can solve the X. Okay, let's check. Okay, this 10 power minus 3, we can divide it. Okay, we can ignore it. So, and 1.143 times 200 minus and plus 3 times 200 minus X equal to 0. And what is X? Okay, let's see. Let's see, do we get this right? Get minus 1.143. Minus 1.143 times 200 plus 3. Okay, and divided by 3. Okay, it's 123.8, and don't forget the units, it's millimeter. Okay, don't forget the units, millimeter. Okay, check yourself, unit millimeter. And it's the answer. Okay, I made a little mistake here. So it's 400 millimeters square. Yeah, I made a small mistake here, but I corrected. Okay, so here is this problem. I hope you can understand why the force of free body diagram of these two forces all point apart, because it's draw a reaction force, because the reaction force is acting on this member. When you draw the free body diagram, you have to draw the force acting on the body you are interested in. And this problem, yeah, you need 3 equation. Yeah, a little more complicated. Okay, not, but still not very difficult. Okay, so I'll start the video here and see you in another video. Bye bye. What? Bye, friends. Where should we close? Where should we close? Close. Where? What is it? Okay. Stop.